Hi everyone, welcome to lesson 2.4, types of functions. In this lesson, we're going to review functions that you've seen already in your high school mathematical career, and we're going to look at some new ones as well. So let's go ahead and get started. Before we talk about types of functions, it's important that we review what a function is. So on this page are all different types of functions, and let's just make sure we remember what the definition is. So a function is something where every input has a unique output. And essentially what that means is it's kind of like a vending machine, right? So every time I press the button -2, I should get out a 5. Every time I press the button 4, I should get out a 6. If I press 4 and I get out a 7, well, then my vending machine is broken, right? So every input has a unique output. I think what most students remember this as is that every X value is different, right? No repeating X values. So we can see it in a coordinate form, just like we see here. We can see it as a mapping. So member mapping is just -3, 2. We map the input to the output, -1, -5, so on and so forth. And we can see it as a graph, where in a graph, if I draw a vertical line, I should only get one X value. So these have to pass the vertical line test, right? And it should only intersect once. If it intersects more than once, then it's not a function. So just a quick little review on what a function is. So let's now talk about specific types of functions. So my first definition is what I see here. And this is the definition where if we notice my n values, my exponent, are going down by 1 every single time until we get to a sub 0, which is the constant. So some examples of this, before I give you the definition, might look like 3x squared plus 2x plus 4. Notice my exponents are going down every single time. Another example, I'm going to give you a little bit of a longer one, would be 6x to the 6th plus 4x to the 5th plus 2x to the 3rd plus, I don't know, 4x squared minus 5x plus 7. Right, so there's another example. And again, notice my exponents are going down, right? Maybe by 1, maybe by more than 1 every single time. So this is called a polynomial function. Ooh, 0. All right, so this is called a polynomial function. Now, there are 3 different types of special case polynomial functions that I just want to review with you quickly. The first of which is this first one where we have my exponent, my highest exponent is a 1. So this is a linear function, right? And my highest exponent is a 1, right? So an example of that might look like over here on the left, join me on the left here, might look like 3x plus 2, right? That's a linear function. The next one, my highest exponent here is a 2. And when we have a highest exponent, something again maybe looks like 4x squared plus 1. That's that's a quadratic function. Right? Looks like a parabola when we graph it. And then last but not least, we have when my highest exponent is a 3. And this is a cubic function. Okay, so these are the 3 different types of special cases when we talk about polynomials. All right, so let's take a look here at 3 different examples. So looking at letter A, you'll notice that my highest exponent is a 1. So we're going to graph and name them. Now, if you have a graphing calculator, I encourage you to graph them first and see if you can figure out what they are based on the picture. But I'm just going to quickly sketch them so that we can review them. So letter A, this is a linear function, right? My highest exponent is a 1, and that's going to look like a straight line. Right? Linear functions get their name because they are straight lines. Letter B, my highest exponent is a 2. So this is going to be, again, a quadratic function. A quick sketch of that might look something like this, right? A parabola. And then last but not least, I have x to the 3rd. That's my highest exponent. That's a cubic function. And that looks, I call it the Elvis hands. That looks like this. All right, great. So those are the 3 that we've probably already discussed in high school, but there are a couple others that I want you to also be familiar with. So the next one is what's called a rational function. So a rational function is the quotient of 2 polynomial functions. Quotient, remember, means just division. So an example might look like a quadratic in the numerator, so x squared minus 4x plus 2, and then maybe a linear in the denominator. So there's 2 polynomials, one in the numerator, one in the denominator. All right, that's a rational function. Another example, just to give you another way to look at it, maybe I have the linear in the numerator, and I have a cubic in the denominator. Okay, so 2 different examples. And last is an algebraic function. So an algebraic function is anything that contains a radical, right? Or anything that contains a square root. So the square root can be, in the numerator, just like we see in this first example. It can also be in the denominator, like we see here as well. And these are going to look a little bit different depending on what the function is. So you can see that this first graph is x plus the square root of x. And this second graph is 1 divided by the square root of x minus x squared. Now, we're going to go into a little bit more detail with all of these as the year goes on, but it's important that you just understand which functions are classified as which. All right, so a quick review. So we have polynomial functions, linear, quadratic, and cubic. Remember, linear, the highest degree is 1, the highest exponent is 1. Remember, quadratic, my highest exponent is 2. And remember, cubic, my highest exponent is 3. Rational functions, again, really quickly. These are examples where I have a polynomial in the numerator and in the denominator. Okay, 2 polynomials have to have a division symbol, quotient. And last but not least is an algebraic function, so any function with a radical. Right, even something as just the square root of x. So these are the different types of functions we learned about today. And feel free to review this video if you need to.